not, I'm actually 10 stories above street level in one of Melbourne's most opulent roof gardens. They're a growing trend in the world's major cities. They're easy on the eye and a clever way to provide green space when real estate on the ground is at a premium. But this is also a hard-working roof. It's an outdoor lab, providing important clues as to how our cities can cope in a changing climate. You see, Australia's cities are hotting up. Our built-up areas are suffering from what scientists call the urban heat island effect.
What we've done is we've taken nature's natural air conditioners, the plants and trees and grass, and replaced them with concrete structures. And all of that stuff absorbs the heat of the day and then keeps re-radiating it out, building it up and up over time.
And it's something we're all feeling the effects of.
In the cities like Melbourne, we're 1 to 6 degrees warmer than our more outer suburbs or rural areas.
But a little bit of green retrofitting could be all we need to take the heat out of the situation. I want to know the difference between a roof like this and a roof like this. Studies from the Northern Hemisphere show that you can keep the cold out and the heat in by adding a green roof to a building. But in warmer climates, vegetation can also cool a building down. This is how. Plants provide shade and another layer of insulation on the roof, which keeps the temperature of the building down. And when it rains, the plants soak it up and later release it through evapotranspiration, which provides a further cooling effect. But we've just not known how green roofs can cope with Australia's extreme climate until now. Here in Melbourne, a 3-year collaborative research program is underway to test their resilience and effectiveness when faced with extreme heat, drought and the occasional downpour.
We're looking at the plants and substrates which will work under Australian conditions, and we're also looking at the temperature of the green roof and how that is modifying the temperatures in 2 identical rooms below.
Today's meant to be a top of 27 degrees and it's nice and sunny, so how hot would that make the roof?
Well, the roof's made of bitumen, a bitumen covering. The temperature of the roof is already 44 degrees. It's been in the sun for about 4 hours now and it's really absorbed a lot of heat.
Actually, yes, my thermal camera confirms that, says it's officially red hot.
Okay. So in here, the pathway, which is made out of blue metal, is about 33, 34 degrees. And when we look at the scoria substrate, it's about 27, 28 degrees. But then when we look at the plants, they're a lot cooler, and they're 20 degrees, 21 degrees. So
yeah,
the evapotranspiration which the plants are doing is cooling them and probably the surrounding area a little bit.
Actually, I can see that here. We've got some nice cool blue blobs there where those plants are. Using the data from the University of Melbourne Test Garden, CSIRO scientists have worked out that the energy needs for the building's air conditioning can be reduced by 48%, and in winter the heating needs reduced by 13%. Scientists are also hopeful that green roofs can help us manage Australia's changing rainfall patterns. We're experiencing more heat waves and less frequent but more intense downpours, and this is causing huge problems.
When we urbanise an area, we basically take away the natural sponge that a forest essentially is and replace it with a whole lot of hard surfaces. When rain falls on those, it's got no chance to infiltrate, and so it just rushes off very quickly, taking with it all its pollutants and causing lots of problems of erosion and flooding.
The team at Monash University are testing 3 types of roof covering to see how effectively plants and substrates can be used to manage the flow of rainwater. We've got roof acting as a sponge plus evapotranspiration, and then this is our control.
Exactly. Okay, so we'll use this rainfall simulator to put a rainfall event over the roof for about 2 minutes. We'll put about 40 litres on, and that's equivalent to about 200 millimetres an hour. So it's a nice, short, sharp burst of rain. We'll see how it behaves.
So that's only 15 seconds and we had water in the gutter, and then 23 seconds and it's reached the bucket. Next to be rained on, the sponge-like scoria substrate. Well, that's good. After 2 minutes, we're still not seeing any flow come through.
Yeah, and we've now applied 15 mil of rainfall, which is a pretty heavy rainfall event. Given that we didn't see any flow at all coming out of the substrate, I expect that we'll see the same here. After the rain stops, the plants will evapotranspire and draw that water back up into the atmosphere, and that means that the sponge is empty for the next storm.
So I could make myself a cup of tea while I'm waiting for this water to come through. Stormwater management is just one of the elements being road tested at this new community centre. It's It's been specially wired to measure temperature and moisture levels while testing out a range of substrates and plants, bringing all the research under, or rather onto, one roof.
This is a piece of drainage layer, and this actually has sort of revolutionised green roofs over the last couple of decades because they're a plastic cell that sits on top of the roof and allows drainage through the profile, so through the substrate and out of the system.
Oh, yep, I can see those holes there. I was sort of surprised to see that there's solar panels on the roof, which means that there's less plant cover there.
Plants are actually very useful around solar panels because solar panels start to decrease in efficiency once the temperature moves beyond 35 degrees. So having plants that cool the environment around solar panels actually can increase their efficiency.
In the bigger picture, green roofs are part of a design philosophy that views cities as living ecosystems, which provides benefits not just for the birds and bees.
Psychologically, physiologically, we like to be connected to nature, so it gives us a happier and healthier workplace and living environment.
So maybe it's time for our cities to literally grow up. And if that means buildings that are cheaper to heat and cool, cities that are more resilient to the effects of climate change, and urban spaces that are just more pleasant places to chill out, well, I'm all for a bit of green skies thinking.